When we're modeling T-junctions, you may find that you have a warning message like we see with this particular T-junction here, okay? And the warning message here is the idle check T relationship is outside the allowable range, okay? Now there's a range limitation for the idle check T relationship, okay? And it just goes on to describe here at the bottom, for this T-type, the calculated K values have a range limitation. The area of the branch and straight pipes must be greater than the channel pipe area, or the straight and channel pipe area must be identical. Okay. Now, if we look at the input tab, we can see, sure enough, the T definition is idle check. The software has four options to choose from: idle check Miller, Crane, and SAE. Okay, now idle check Miller and SAE take into account different sized pipe connections at a T junction. So, for instance, a reducing T, whereas the Crane relationships do not. They're a much more simplified pressure loss relationship. Okay, so for instance, if I was to choose the Crane relationship for that particular T junction and recalculate this model, this warning message will disappear. But now, remember, warning messages are here to help us develop a more efficient design, okay? Now, the first thing we would notice for this particular T-junction is that the branch pipe connection with the red dot is assigned as pipe minus 15. And you can see this is pipe minus 15. And sure enough, the little red dot, let me just turn off the warning there. The little red dot is shown assigned to pipe minus 15. Okay, now let's look a little bit closer at this T-junction. We've got flow coming in from the top, flow continuing straight on through the straight, and flow out of the branch connection. Okay, so we've got a diverging T-junction here. Okay, now at the moment, the branch pipe is shown as minus 15, but actually it's pipe minus 141, which is the branch connection. Okay, and if you look at the nomenclature field here and expand this, there's a little description for the different combinations of flow at T junctions and, of course, Y junctions. So if we look at the T, for the converging combining case, we've got flow merging at this point to form the channel or combined flow. So the red dot is assigned as the branch connection. Look at the diverging dividing case. We've got the combined channel flow arriving at the T junction and then splitting or diverging like so. And you can see once again the red dot is assigned as the branch connection for this T junction. You'll notice as well that the channel is assigned the red dot in the case of a Y junction. Okay, so Y junction, channel being the combined flow at the junction. Okay, so since we have a T junction, we need to reassign this red dot to pipe minus 141, and you can just simply double click within this cell like so, and you can see the red dot reposition on screen at the T junction. Or you can click on the little grey box so you can see it move around, and now we've got pipe minus 141, and it's now showing exactly where we want it. And you can recalculate the model at this stage to refresh all your results. Now, it is very important that you set the branch pipe connection correctly at T junctions, because it does have an effect on the pressure loss calculation at the junction. And this becomes more and more important when modeling systems such as gas or two-phase systems. Okay, so you want to have a high level of accuracy. Now, this model is solved, and the warning message associated with that T junction is now eliminated. It's gone. So we've resolved that particular issue, and we've actually fewer warnings as well. So we can then review some of the other warnings in the model. And with a view to optimizing the design, such as low pipe velocity and high pipe velocity and so on. And you can see if I click on any of these warning messages, it automatically finds the relevant component on the network. And if I look at this other T junction warning message, it's saying that the flow through the T is unstable at T node 46. Okay, and this just means that the flow direction through the T junction is constantly changing. Instability prevents a solution, and so to avoid this, fluid flow has closed the unstable connection pipe. You should reconsider the design approach at this particular junction. Okay, and all that really means is that at this particular T junction, the flow through one of the lines is extremely low, and hence, there's potentially no flow in the line. Okay.